I'll discuss about new concept, that is fluid dynamics, right? So listen to me carefully, Peter. It's highly important, and I can say easy as well. Easy, I mean to say, if you have a basic grip, like say mechanics, if you are literally pretty confident in mechanics, then you will enjoy. If you have a problem in mechanics, solving the numerical, then that is a problem, right? So listen me carefully, everyone. So now, student, in today's class, I'm going to discuss. This is what, my dear, fluid dynamics. What, my dear, fluid dynamics. Okay, so beta, in our syllabus only mentioned what? Beta the ideal fluid, right, my dear? So for ideal fluid, student, already I can say properties of ideal fluid. Already I said, but I'll repeat one more time, right, my dear? Hare Krishna Tharva, how are you, my dear? Okay, so beta, property of fluids. Beta, what is the first property of ideal fluid, my dear? That is non-viscous fluid. What does it mean? There is no friction between layer of fluids. Very good, my dear. Now, students, I can see next. Already I see these all points. Just I'm repeating. Next beta, I can see, just I'll write here little points. I can see for properties of fluid, just for revision, my dear. This is what is today properties. I'll write in short properties of fluid. So beta, this is first one. What was the non-viscous fluid? What, my dear? Non-viscous fluid. What does it mean, bacha? There is no friction at all. There is no friction at all. Daivik beta, Hare Krishna beta, how are you, my dear? Okay, beta, point number 2 here. That is, students, non-compressible flow. Students, this is non-compressible flow. Okay. Now, beta ji, I can say next, beta, what? No, beta, there are two streamlines never intersect each other. Yes, beta. At this point, beta, I didn't say the student Dabik and Atharva in your classroom, my dear, right? So keep in your mind, bacha, two streamline flow, student, two streamline flow, beta, never intersect each other. Beta, keep in your mind, bacha, two streamline flow never intersect each other, because at a single point there is two possible directions, which is not practically possible. At a single point, my dear, at a single point, beta, there is two possible directions, which is practically not possible, right? We are considering that fluid is showing irrotational effect. What does it mean? Considering no torque, only what? Movements. What I said in the classroom, angular momentum at anywhere, at any point, will be 0. So this is beta point. Just I repeated only, beta, I can say, for properties of ideal fluid. Now beta, I'm going to start, beta. That is, student, next concept for fluid dynamics, which is known as, my dear student, which is known as, I can say, beta G, this is what? Equation of continuity. What, my dear? This is equation of continuity. Yes, beta. So now, students, I can say for equation of continuity, students, equation of continuity, right? So beta, what does it mean here? Defines that stationary flow for a fluid. What is, student? Defines for a stationary flow of a fluid, right? Student, just take example. Let us suppose, beta, I'm considering here there are two cross section. The student, here I'm considering here, this is, there are two cross section, my dear. There are two cross section, my dear, right? Okay. Now beta I can say students, you can say beta ji, this is the point I'm calling beta point inlet point. You can take my dear student this point, you can write beta this is point B. Next beta ji, let us suppose I'm considering here a student inlet velocity. Student, here I'm considering student this is what inlet velocity. Let us suppose I'm calling v1 my dear. Okay, now student this is outlet velocity which I'm calling this is v2. It's not beta, it's v1. You can see this is inlet velocity my dear. v2 is what beta, you can say this is what outlet velocity. Okay, fine beta. What is the basic sense of this entire things? Equation of continuity beta depends on what? Conservation of mass, or beta what you can say, mass conservation. Equations of continuity depends on a student mass conservation. Okay, so simply you can say bacha party what student, you can say beta mass inlet, mass flow rate. Student, you can write here this is bacha ji mass flow rate dm by dt. Beta I hope flow rate all I can say all of you know dm by dt. Aditya Hari Krishna beta dm by dt student this is inlet beta ji. As I said mass flow rate beta, you can say equations of continuity depends on mass conservation. So student, now I'm going to conserve the mass. What beta? dm by dt inlet is equals to student this is dm by dt beta ji outlet. What bacha ji? dm by beta mass inlet. Beta don't be a swamp bacha please. Student, don't be a swamp please. Leave the meeting beta. Leave. Don't disturb bacha for live session. Don't write anything unwanted beta ji. Leave live session only. Don't spam unnecessary thing. Here student just joining for learning only. Atharva I'll do beta. Already one day beta Atharva I saw there is one boy unnecessary they were writing. Unnecessary talk not allowed over here. Everyone just join here for I can say I'll do beta. I'll do the big. How can you do? Can you tell me here? I don't know too much. Wait, I'm looking options. Yes, I did beta. I did bacha. Yes beta, I did. Now I'm just concentrating to teach here my kids. My kids joined the class. In fact, I was delay, and they joined for learning. And how this Ravi's voice is doing unnecessary thing in the classroom. Beta, equations of continuity, my dear. Just we continue here. Focus here only. I did beta. I removed beta Atharva. Beta equations of continuity my dear, dm by dt. Beta mass inlet is equals to beta what? Mass outlet. Simple bacha party. Okay. Beta I hope here mass you can write beta. Be remember here. You can write beta mass is what my dear? Mass is equals to density into volume. Mass is equals to what bacha? Density into volume. Okay. So beta I know mass remains in bacha. So you can write bacha. This is what remains density beta. Rho only. You can tell my dear this is the density of water. This is remains rho only beta. Okay. Volume beta what we can write? This is what? Area into length. What bacha party? Area into length. But let's for consideration here. There is what? But a little change. Right. Let us suppose this is what? How much? It's a dx. So beta this amount beta I can beta we'll go through this. Student, good evening. Jai Sri Ram student. Okay. So beta this is what dm by dt mass beta I wrote rho into velocity bacha party. So this is what you can write rho bacha. Beta this is area of cross section here. You can take beta a. This is what beta I'm considering a beta, or you can say a1 into bacha what you can write dx by dt of beta g, you can say for one cross section is equals to my dear rho remains same beta this cross section you can take a2 my dear. This is dx by dt of 2 beta g. You can see easily, sir, rho and rho cancel. Advik beta, Hare Krishna. Now beta, dx by dt, I hope beta all of you remember here. You can write, my dear, dx by dt. Beta ji, everyone you can write dx by dt. It's nothing but its velocity bacha. So dxt by dt for one bacha. So I'm writing this is a1 v1 is equals to beta a2 v2. a1 v1 is equals to a2 v2. a1 v1 is equals to, my dear, this is what, a2 v2, right? So beta, I can say this is here first, beta, in dynamics bacha, this is highly important bacha. In dynamic bacha, this is highly important student. What we can say, a1 v1 is equals to a2 v2 bacha. Okay, now beta, I can say after this beta, I can see this, we can do your basic questions. We can do, my dear, basic questions. Okay, beta, everyone there take snapshot beta, just make diagram, make notes, everyone. Makes notes beta, each and all candidate beta, it's highly required, my dear. Take snapshot. I wanted to turn the page. Hi student. Now beta, good beta, good, my dear Atharva. Okay bacha, I can see beta, for next question just answer me this question, everyone. Very good Atharva beta, very good. I'm proud on you, my dear. I'm proud on you, my dear. Okay, beta, what's the question is? Have attention, everyone. You can take beta, this is what? Kinds of beta arrangement. Right. This is, students, you can say kinds of arrangement here. Right. So now beta, this is a very practical situation. Beta, once water coming beta from tap, beta, this is what? You can say, sir, this is what? Thick. Beta, I can say outlet point is what bacha? Thick only. Leave beta, Atharva. Beta, be focused on lecture bacha body. Okay, so you can see bacha for timeline here. Beta, once water coming down bacha, so what you can say, sir, this is what? Becomes thinner. Beta, here beta, what you can say, at tap point bacha, this is what? Bacha, the outlet is, I can say thick. Now bacha, you can say beta, for this condition, this is what? You can write bacha party thin basically. Right. Student Jai Sri Sham. Now beta, I can see for this condition, what we have to find beta ji. You can take beta area of tap. Student, you can take area of tap. That is something, tell beta, what I have to take? Daivik beta, what I have to take? Bacha, I am teaching beta fluid dynamics beta. Student, I am teaching now fluid dynamics. Atharva beta, tell. हाँ बेटा, A1 बच्चा, टेल मी बच्चा पढ़िए. Okay, Daivik, what? Okay बच्चा, I'll take बच्चा Daivik your data. No बेटा, because in live, why I'm feeling comfortable in live season here? Because बच्चा जी, we are connecting each other here. That's why I'm taking live class only बच्चा. Live class meaning beta, just connect the maximum candidate and teach entire India बच्चा. Okay, bacha, buddy. A. Let us suppose, beta, just tell me this height, beta. You tell Atharva. Atharva, you tell what I wish to find here. What is the velocity over here? Atharva, tell beta this velocity. This length you have to tell only. Height. Okay, you tell me, beta. That is the area, bacha. That is area I have taken. Area of tap. I wanted what is the height. Tell me. 9 meter. Okay. Okay, beta. So you can take here. This is 9 meter. G is student. You can take beta G. G is equals to 10 meter per second square. Beta, one more thing, my dear. Beta, you can take U beta. Initial velocity of beta, I can say tap. That is beta G 10 meter per second square. Student, you have to find what is the bacha ji for this condition. What is area? You have to find beta area here. Yes beta, you have to find area at 9 meter. Area at beta 9 meter, or it is beta area at point P. Area at point P. Do bacha party. Okay, good. Okay. Atharva already answered the question. Okay, fine. Okay, same answer. I can say there are 2 candidates. Okay. Very good, bacha party. Fine, very good yaar. I'm very happy to see bacha all of you. Okay. Now beta, I'm going to solve here. Very good. Beta 10 candidate present in live session yaar. 11 candidate, and I can say like maybe all of you didn't like everyone's session of the class here. Like only 6. So now beta have a look solution student. Okay, beta in step 1, beta first we have to find beta this velocity. First beta we have to find this velocity here. So for getting beta this velocity, what we can apply? Okay, yes Davik, I knew beta. Davik and Atharva did in beginning of class only bacha. Beta step 1 bacha, you can apply beta equation of motion third. V square is equals to beta U square plus 2as. Okay, now bacha V square beta BB is to find. Beta U square 10 10 100 my dear. Student 10 10 100 here, plus beta 2 into beta what is A? Beta falling under gravity here. So you can take 10 bacha only. 10 into what? 9 bacha. So this is what? 90, 180 bacha. So you can say V square is equals to 100 plus bacha. This is what? 180 beta ji. So V square you can say this is what? 280. So V beta will get 280 meter per second. Okay, step 2 student, apply. Student in step 2 bacha, you can apply simply bacha party. Student for this condition bacha, you can write that is what my dear. Okay. Beta step 2 bacha party. Done beta. Diving done beta. Unnecessary person. Student use beta equation of continuity. Student use. Yes beta, I done bacha. %100% MSc. I didn't get it. Equation of yes beta Aditya, go beta. Yes beta, or you can just be in the meeting, just at least watch the video. Oh, MSc, okay, fine. That beta, I'll be care bacha buddy. Beta, equation of continuity have just be concentrate or beta contained A1 V1 is equals to beta ji A2 V2. Beta A1 beta what? This is 10 centimeter square here. So you can write beta 10 into beta 10 to the power minus 4 beta g meter square. V1 bacha how much? 10 bacha party. Beta this is A2 bacha, what you can say? A2 beta BB is to find my dear. And V2 beta we already got here. Root of 280. Okay, beta just beta do some factorization here. 280 beta how much? 10 into beta 28. So you can see bacha this is what? 2 into 2 into 7 into beta root 10. 2 beta can take common here. This is what? Root 70. 2 root 70 here. So bacha party you can see this is what? 10 into beta 10 to the power minus 4 into beta g 10. Beta this is A2 bacha. This is 2 root 70. Beta, I can say this is what? 2 5s are 10. 5 10s are beta. This is what? 50 into 10 to the power minus 4 a2 beta. What's the root 70 bacha? Anyone from all of you answer me finally beta. What's the answer for these questions? What's the answer bacha party for this question? Anyone answer me? Same approach. Okay. So what's the answer bacha? Tell me. 0.01. Okay, fine. I'm considering your answer beta. Okay. Root 78.3. Okay, 8.3 bacha finally. So you will write. Okay, fine. Fine bacha buddy. So a2 beta what will get? 0.01 beta ji meter square. Very good bacha buddy. Okay. Now beta just have a look here. Next question. Next question beta Atharva. Very good beta. I'm very proud on you beta everyone. Okay. Students, just have a look. Beta today, tomorrow beta, Daivik, Atharva, I can say Advik. Student, I'll do like dynamics. Saturday beta, bacha party. Daivik, you can go bacha, but at least try to listen the beta session. Daivik bacha, try to listen bacha session here at least. Once you will finish beta dinner here, then beta we continue. Yes beta Daivik. Good Aditya beta. Okay, beta leave attention everyone here only. Beta you can take care. This is students 5 meter per second. Beta area I'm just taking bacha. This is you can take 30 mm square. 30 mm square. Bacha ji this area beta. This area beta you can take this is 10 mm square. Beta we wish to find beta this velocity. Beta you can take this area that is beta z 15 mm square student. Beta this velocity you can take this is 9 meter per second. Beta we wish to find this velocity. Student we wish to find this velocity. Beta questions. Is it clear everyone? Questions? Beta this is 30 mm square bacha 5 meter per second. 1 minute. Okay. Good beta Atharva. Do. Okay beta. Advik. You can take your time bacha. Oh, Atharva already answered. Very good Atharva. Very good. Very good beta Atharva. Okay, fine. So now student, I'm going to solve this question, my dear. Listen me carefully everyone. Right beta. So I can say for this condition, simple beta, energy conservation you can apply. Or beta can think like that here. What is beta? Initial velocity of this beta. I can say this what? I can say initial inlet velocity or initial inlet amount of water. This inlet amount of water got divided in two parts. That's all bacha party. So here beta you can write this is A1 V1 is equals to A2 V2 beta plus bacha ji A3 V3. Okay, good beta Advik. Beta wait my solution bacha. Beta I'm considering bacha this is A2 V2. This is bacha party A3 V3. Okay beta good beta Advik. Beta just wait. So beta A1 bacha how much? Beta this is what? 30. So 30 into beta 10 to the power minus 6. V1 bacha what we can say? 5. A2 bacha 15 here. So you can write 15 into 10 to the power minus 6 into beta ji 9 plus beta A3. This is 10 into 10 to the power minus 6 bacha. This is V3. Okay. you can say, sir, this is finished. Beta 35 is beta this is beta ji 150 is equals to 15 into 9 beta how much 135 plus beta what we can say 10 times of v3 beta 5 times cancel each other bacha. So beta 150 beta this is what you can say beta 15 only. Correct here. Correct bacha already answered here. This is 1.5 meter per second. This is what is 1.5 meter per second. Okay, Arun beta, you are lucky because now bacha just I started fluid dynamics here. Very good, Advik. Advik Atharva, very good bacha. So just beta, just stay in live session bacha. I can say Arun, beta, you will get benefit bacha. Literally bacha, you will get benefit. Okay, student. Now I'm going to beta start next concept. Next beta ji, Bernoulli's theorem. Student. Sir, good. Very good. I'm proud on you, beta Arun. Arun, beta, I'm proud on you, bacha. Okay. Now, beta, have a look, everyone here. It's Bernoulli's equation. Bernoulli's equation, right? So, beta, again here, now I'm going to teach you work power energy. Now, student, I'm going to teach you work power energy. Okay, students, look, everyone, attention. Let us suppose, beta, you can take this is what inlet container or inlet, you can say inlet position of the tube. Now, students, this is I'm considering with outlet position. This is what, my dear, outlet position, right? So beta, take consideration here. This height from here, nothing but, my dear, it's h1. This is what, my dear, s2. Okay, beta, what is h1 s2 beta? Note down with me, everyone. This is what, my dear, gravitational head. This is what, my dear, it's a gravitational head, right? Beta h1 and s2. You can take, students, for this cross section, it's an inlet, my dear. This is a1 v1. Bacha, here you can take, my dear, for outlet a2 v2. What, my dear? Outlet a2 v2. Okay, students, take as a consideration, let us suppose in time dt, my dear, in time dt beta, there is what, little displacement. Student, in time dt, there is little displacement. Okay, so students, you can write over here. You can write, bacha, what's the displacement here? Here, student, I'm going to use definition of velocity is equals to displacement upon time. So let's take beta, there, this is what, time becomes beta dt to travel this much displacement. So this displacement, student, you can write, this is what, v1 into dt. What, beta, you can write d1 v1 into dt. Now, students, this is beta, if you can say, sir, this inlet part is moving beta towards right. So same beta, you can take for consideration, this part, student, again will goes bacha ji like this. Okay, so this is beta consideration which you can take in your mind. Okay, fine. Bacha ji, what's the point which you can keep in your mind? That is what, mass inlet, my dear, mass inlet is equals to, student, this is mass outlet, right? So beta here you can write what is mass here, density into volume. So density beta, what you can see, this is what rho 1 into beta what's the volume here, area beta, this part you can say a1, what's the displacement, v1 into dt. So you can write my dear v1 into dt. So I wrote mass is what, density into volume is equals to student, this is what rho beta remains same, so no need to write beta rho 1 rho 2. For your convenient I'm writing beta rho 1 is equals to rho 2, which is equals to rho 1 is equals to rho 2, which is equals to rho. Okay, now bacha you can say rho 1 a1 b1 dt students, which is equals to rho 2 a2 v2 into dt. Right bacha party? Okay, correct. Now bacha I can say rho 1 a1 b1 dt beta, rho 2 a2 v2 into dt bacha party. Okay, now bacha I'm going to use work done by pressure at inlet. Bacha I'm going to use over here beta, that is work energy theorem, right? So this is what my dear, you can say work done total, which is equals to change in kinetic energy, which is equals to my dear change in kinetic energy. So what is work done beta, who will do work done over here, work done due to pressure only, pressure pushing over here. So we can write my dear work done by pressure at inlet, work done by student pressure at inlet minus beta minus student work done by pressure at outlet, which is equals to beta change in kinetic energy. Now students, work done at inlet, what is beta work done formula here? So student, here I am writing beta for inlet, force, students force into displacement, the inlet minus student force into displacement outlet, which is equals to beta the change in kinetic energy. What is the force beta over here? Force is what, pressure into area. So beta for this one here pressure I'm considering P1. Student, for here I'm considering beta pressure P1. So this is students P1 A1 V1 into dt minus P2 A2 V2 into dt, which is equals to beta kinetic energy final. So this is what my dear, half m is beta, you can write beta this m, half m v square. So this is beta v2, this is v1 bacha, half m1 v1. So here beta I can write half rho 2 a2 v2 into dt beta the v2 square minus my dear half rho 1 a1 v1 dt beta g v1 square. Okay, so bacha party this condition here, because you know there is a beta change in kinetic energy here, we'll also go through, because beta what I can say, you have to add beta everywhere work done due to gravity as well. So better for us bacha change in kinetic energy, because work done due to gravity. This is work done due to pressure bachcha, and next side also we can write work done due to gravity. So here beta just simply you can add plus, this is what bachcha party m. I'm just considering here this entire value is m only for easy calculation. So this is what beta you can write, this is m g s2 minus student, what we can say, m g h1. Okay, please listen carefully everyone here. We can cancel few part. Student, we can cancel few part. That is what you can say everywhere. A1 B1 dt, A1 B1 dt, A2 B2 dt. It's nothing here. It's what? We can say mass, because rho remains common everywhere. So beta this terms, student, you can do cancel. A1 V1 dt, A2 V2 dt. Then again beta A1 V1 dt, A2 V2 dt, and beta mass. This is finished. This is finished. So what is terms beta we have? Basically you can write, this is what my dear, P1 minus P2. Good beta Atharva. P1 minus P2 is equals to beta half, what beta party you can say, V square. Half beta party rho beta, because you can't say rho this side beta. So what you can say, P1 minus P2 half rho 2, or rho remains same bachcha, rho V square plus beta g gs2 beta. In terms of rho beta we can write everywhere. So just be careful here. Just beta take snapshot here. I'll write a final expression. Beta, God bless you beta Divya. Okay beta. So here is student, I'm writing here, there is some terms space is not sufficient here. Student, the space is there is not much sufficient here, so I'm writing entire terms again beta. So beta finally I'm writing here, this is one more time, work done total is equals to beta ji change in kinetic energy. So beta ji work done total beta, what can I write? But I need to pressure here. I'll write with a small so that I can write everything in a one line. P1 beta g P1 A1 V1 dt minus bachcha party P2 A2 V2 into dt. Beta this is work done due to pressure bachcha is equals to beta, you can write, I hope all of you remember song here, kinetic energy final plus potential energy final minus bachcha party kinetic energy initial plus potential energy initial. Oh, very good Atharva beta. Very good Atharva beta. No. You are doing very good job bachcha. So this is beta, I'll write here beta P1 A1 V1 dt minus P2 A2 V2 dt. Beta kinetic energy final here half bachcha rho bachcha ji, you can say this is beta ji A2 V2 dt beta half m bachcha ji V square plus beta this is what beta mass, what we can say, rho A2 V2 dt mass beta g into beta h2 beta g I can say minus, I can write here only half rho beta this is A1 V1 dt V1 square plus rho A1 student rho A1 V1 dt g into beta g h1. Okay, fine. Now beta you can see here terms cancelling each other, because you can beta see this derivation here, A1 V1 is equals to A2 V2, right? So beta behalf of this my dear, you can say cancel A1 V1 dt from here beta, A2 V2 dt here bachcha, again here A2 V2 dt here beta g, then beta A2 V2 dt here bachcha g, then beta A1 V1 dt here beta g, A1 V1 dt beta g here beta g, right? So what we have only P1 minus P2 beta. Yes sir, cancel. Very good beta Advik. I'm feeling proud here to see everyone in live session. Thumbs up. I'm proud on you beta. So this is, I can say P1 minus P2. Someone is writing, sir, we can't see. Definitely, Daivik said something correct only. Daivik said something correct only. Okay, disturb me. God will disturb you. Don't worry. P1 minus P2 is equals to beta. I can say half rho V2 square plus beta G, what you can say rho GH2 minus beta half rho V1 square plus beta G rho GH1. Simple beta. You can write beta party this beta P1 this side, beta P2 this side. So you can say beta P1 beta entire terms beta take left side. So P1 plus half rho V1 square plus rho GH1 is equals to beta G P2 plus half rho V2 square plus rho GH2. Super beta G. So now here I can see this is beta result finally you can write. So now beta G further you can tell for this consideration beta G for this condition, this is the result we got here. P1 half of rho V1 square plus rho G beta G H1 plus P2 half rho V2 square plus rho G S2. Beta finally you can beta just take in consideration my dear P plus half rho V square plus rho GH beta G which is equals to constant. P plus half rho V square plus rho GH is equals to beta, you can take this is what constant. Okay, fine. Now student, just remember one thing here. Beta, no, this is what known as beta this P. Beta, these all are beta student. This is the question already asked by JE, right? So beta, you can write pressure, energy, density. P beta, what you can say? This is what my dear pressure, energy, density. Beta, this is you can say bacha kinetic energy density. Kinetic energy density. This is students you can write potential energy density. What was party? Potential energy density. Okay. So beta, you can say sir how you wrote these all things. Beta, I can explain you, right? So let us suppose beta, try to understand their things. You can say sir this is kinetic energy which is equals to half mv square. What was the party? Half mv square. But I'm telling you, bacha, you can take kinetic energy per unit volume. So what you can say half m upon rho into v square. Beta, I said yesterday also in classroom student, something per unit volume. Beta, what you can say? Density. Something per unit length. What you can say, bacha? Basically, you can say gradient. So this is beta what? Half of rho v square here. Beta what we can say? Half of rho v square bacha party. So you can say bacha party for this condition. In fact here mass per unit volume I have to write na beta. Someone wrote gradient. Correct. Advi bacha. Correct beta Atharva. M upon beta what you can say volume. And this is what beta? Mass per unit volume. What you can say? Half rho v square. I hope beta you got it. Now bachaji, something here I can generate the same thing from here also. How? Beta, take snapshot. Student, I wanted turn the page. Okay, I hope all of you taken. Maybe all of you already written. Yes. Good beta Advik. Now beta I can say next candidate. This is what my dear U is equals to mgh. beta just again we can take beta same consideration, beta u per unit volume. So this is what m upon b bacha g into h here. So what we can say, this is what energy beta what gravitational potential energy density, beta rho gh we have no beta, this is rho gh. So this is beta what you can say gravitational potential energy density, beta this is terms bacha you can write gravitational potential energy density, gravitational potential energy density. Okay, fine bacha buddy. So next bacha, just in last year I wanted to give you one more relation, beta pressure upon rho g plus beta g h plus beta g v square upon 2g, which is equals to constant. Adivik, beta can you tell how it came, what I did bacha buddy, how it came? Beta this is a relation here, we remember p plus half rho v square plus rho gh. Beta divide every side here by rho g. Beta every side bacha buddy divide rho g here. This is what rho g, this is what rho g, then cancel beta g, you can write here p upon rho g plus beta g v square upon 2g plus beta g h. Beta what you can write bacha p upon rho g, beta what you can write bacha p upon rho g. Oh SR01 when is joined the session. Okay, beta p upon rho g bacha you can write my dear, this is the pressure. You are literally very lucky person, I can say bacha literally you are very lucky here. SR01 beta p upon rho g, students this is pressure head. Okay, beta pressure head bacha, h is what bacha buddy, h is now beta just only practice session here, theory finish for today class beta I finish theory here, I'll do the only numerical now onwards. Okay, fine my dear, I'm proud on beta SR01. Beta h beta what we can write, this is gravitational head and beta v square by 2g bacha. No beta this is the terms beta SR01 Advik Atharva, I can say all of you active here in the session, so I'm calling name of all of you only. Beta this is the terms beta g asked by J bacha. Student God bless you for your kind word. Now bacha v square by 2g bacha, you can see this is the velocity head, this is what velocity head. Okay, now bacha but theory beta finish for today class beta. Now we are just everyone look beta once, I'm showing bacha SR01 for you beta because you are a good candidate. SR01 bacha, SR01 today beta you started beta this much only theory beta. Properties of liquid beta already I said in the classroom multiple time, I hope all of you remember beta. For today class this is beta new things for you, that is equations of continuity beta. It's nothing else, it's a common principle, mass inlet is equals to beta what you can see mass outlet bacha. A1 you can beta forever use this relation, A1 V1 is equals to A2 V2 beta. So keep in mind formula for coming numerical. Now students I can say next bacha party. Okay, no beta I can see bacha Atharva now we'll do practice. So at least na he has to aware what's the things he has to do in a classroom. Then beta I can see this is one numerical here, that is again beta same principle A1 B1 bacha. This is the inlet velocity. Inlet velocity student got divided in two parts bacha, right my dear. Okay, then bacha I proved one knowledge equation. So nothing beta here again easy for you. because you are lot practice with me in the classroom. That is work energy theorem, bacha. So entire explanation based on work energy theorem only, bacha. So finally, beta, this is the result which I got: P plus half rho B square plus rho G, which is equals to, my dear, constants. So there are different names which you can keep in your mind, bacha. But this P, you can say pressure, energy, density. Half rho B square, beta, you can say kinetic energy density. Students, you can say kinetic energy density, beta. Rho Gh, bacha, you can write gravitational potential energy density. Beta, rho Gh, bacha, you can write gravitational potential energy density. Beta, after this, bacha, I can say Jay, beta, already asked my dear these questions. So I'll give you first, bacha ji, I can say question based on, bacha, like theory only. Then, beta, I can say this is the last. Maybe, beta, you joined here only, bacha, SR01. So just keep in your mind, bacha, but P plus P upon half of rho G. My dear, P upon half of rho G. P upon rho G, not half of, P upon rho G plus, beta, the H plus V square by 2G is equals to constant, beta, P upon rho G. You can see this is the pressure head. Beta, God bless you, dear. Now, because SR01, you are good, right? Just you need little support, like Atharva, Advik, all of you three are too much active. One new candidate, like those who said you are the best teacher in literally, no, literally, beta. That's why I joined YouTube, because I knew how people, I can say, just teaching on YouTube and in classroom. Here, student, you will get everything in beta sequence way. Students, here you will get each and everything beta in sequence. Even you will enjoy a lot. You will enjoy a lot in the classroom. That is my promise. Okay, beta. Do everyone questions here once, everyone. Beta, with me. Do beta practice session here. Now competition started here. Everyone be active. Beta, I don't have a time here, so I'll give you data beta only, right? Time is beta. I have very less. At least do beta 2 to 3 questions in the classroom. But you can see water is beta, note down everyone data quickly. Water is flowing through a horizontal tube of a non-uniform cross section. Beta, you can take diagram like this. Beta, this is my dear, you can take this is non-uniform cross section. Yes, beta, the non-uniform cross section. Beta, at a place of radius of tube is what, 1 centimeter, and beta velocity 2 centimeter. What will be the velocity of water where radius of pipe becomes 2 centimeter, right? So, bacha ji, ultimately what they ask here, you can say easily. Bacha, you can take, beta, this radius, beta, inlet you can take. I'm writing here inlet, you can take, bacha. This is just tell, beta, what I have to take, bacha. Advik, beta, what I have to take, beta. Tell, beta, inlet radius. Advik, bacha, what I have to take, beta, inlet radius. Inlet radius, beta. Advik, inlet radius, tell me data. Okay, 4 centimeter. Good. Beta, 4 centimeter. Okay, you tell, beta, I can say, bacha. SR01, bacha. Tell, beta, this is R1, bacha, party. Beta, this is R1, my dear. This is R2. Beta, you tell, beta, R2, SR01. SR01, bacha, you tell, beta, R2. Okay. 6 centimeter. Okay. Now, beta, tell, beta, inlet velocity, bacha. Bacha, tell, bacha, inlet velocity. हाँ बेटा, okay. This is okay, 3 meter per second. Atharva said 3 meter per second. Beta, what is data bit all of you we have taken here? R1 and R2. R1 and R2, beta, what you have taken data here? Tell me. R1, R2, beta, radius meter or centimeter? Dimension. Okay. I have taken 3 meter per second, bacha party. Just tell me, just confirm this one here. R1, R2. R1, R2 in terms of SI or CGS? Okay, centimeter. Everywhere, centimeter. Okay, fine. So I'll change, bacha, this one. This is what, centimeter per second. But you have to find here, I can say, bacha ji, you have to find, bacha, what is the velocity. B2 you have to find. Tell me everyone fast. In today class beta SR01 I removed 3%. I removed 3%. Okay, answer me, anyone from all of you. God bless for reaction. I have taken it only centimeter here, don't worry. Okay, 4 by 3. Okay. SR01 4 by 3 centimeter per second. Okay. Advik force. Okay, same answer. Advik and SR01. Atharva. Okay, all of you three answered me correctly. Okay, beta. Now I'm going to solve here. Beta, I can say for solution beta, this is A1 V1 is equals to A2 V2 bacha party. A1 bacha, what we can say? Beta circular cross section here. You can write pi into beta 4 centimeter square. No need to conversion here because answer everyone is centimeter only. V1 bacha ji, this is what? You can say 3. A2 beta, this is what? Pi into beta ji 6 centimeter whole square into beta ji, this is what? V2. So you can say, sir, this pi centimeter square finished. This is only we have centimeter per second. So 4 4 is 16 into 3 centimeter per second. Beta 6 is 36 into beta V2, right now. So you can say bacha party finally as an answer. This is beta how much? 3 cancel beta 12 times. 4 4 is beta 16. So 4 centimeter per second upon beta ji 12. So this is V2 here. 1 by 3 I'm getting. 4 by 3 how? Correct. Correct beta. 4 by 3 beta ji centimeter per second. Very good here. Yes, correct. Now beta, this is answer. SR01 bacha, this is answer bacha buddy. 4 by 3 beta only. Okay, very good here. I'm very feeling beta proud on all of you bacha. Okay, beta, move on beta. Next question, my dear. Good. Correct SR01. Correct bacha ji. The next question here, calculate the beta. Find following. Students, calculate the rate of flow of glycerine of density 1.25 10 to the power 3 kilogram per meter cube. Through the conical section of a pipe if the radii of its ends are 0.1 meter and 0.04 meter, and pressure across pressure drop, you can write beta, pressure drop across its length is 10 Newton per meter square. But I'll repeat question once here for everyone. Sir, I have to go now. Sir, I have to. Yes. Yes, beta, you can go. I'm going to beta just do this question, bacha buddy. I'll just beta today stop class now only because I got beta delay due to some reason. By tomorrow, yeah, be sharp on 9 o'clock only. Chocolate, yeah. Meet me tomorrow. I'll talk to you. हाँ बेटा just do this question अथर्वा do this question बेटा just I'll beta stop the meeting beta for today class. Today live stream बच्चा calculate the rate of flow of glycerine of a density 1.25 10 to the power 3 kilogram per meter cube through a conical section of a pipe if the radii of its ends are 0.1 meter and 0.04 meter here. Radii बच्चा 0.1 meter and beta what 0.04 meter. Pressure drop across its length is 10 Newton per meter square. Okay, so bacha we'll go through here everyone. We have to find what is the basically rate of flow, right? So just listen carefully everyone here. I'll do this question beta, then you can just meet your answer. What's the question here? We have to find volume rate basically. So beta first we have to apply equation of continuity. First make diagram here. Because this is 0.1, 0.04. Okay, so beta take consideration like this. This is inlet. Beta this is outlet here like this bacha party. You can take beta. This is V1 bacha ji. This is V2. Student, this is A1. Beta ji P1. A2 beta ji pressure P2 here. You can take consideration like this. Now students, I'm going to use in step 1 equation of continuity. What bacha? A1 V1 is equals to A2 V2. So you can write bacha V1 by V2 is equals to A2 by A1 bacha. Cross sectional area here, so you can write बच्चा पाई R2 square upon beta pi R1 square. You can see बच्चा pi cancel. So beta you can write V1 by V2. R1 बच्चा party 0.1 whole square here. So you can see 0.01 बच्चा party whole square again here. So what you can write my dear? This is 0.0016. Now bacha, so just do further calculation student. So you can see this is 4 decimal 1 2 3 4 decimal. Beta this is what you can say 1600. This is cancel here. So what you can add bacha party R2 by R1. I wrote wrongly in bacha. R2 is this is R1 bacha. I'm solving bacha. This there is little error bacha. Beta V2. Also bacha next slide here. Okay, so bacha this is my dear V1 by V2. It's nothing but R2 by beta g R1 whole square. Okay, now beta V1 by V2 bacha R2 about 0.04 0.1 bacha ji whole square. So V1 by V2. This is what my dear. Finally you can say here this is 0.04 0.1 bacha party. you can see here 4 by 25. Now beta just remove the decimal and all, just solve further bacha. Okay, beta this we got here v1 by v2 relation from here only. Okay, now beta I'm going to use in step 2 beta for this question Bernoulli's equation, my dear student. Okay, 0.16. Fine, correct beta. So now student I'm going to use Bernoulli's equation. Beta ji Bernoulli's equation here. So this is P1 plus half rho V1 square. Beta there is no pressure head at all bacha. There is no pressure head at all bacha. You can see H0 both of the side. Plus beta ji P2 plus half rho V2 square. So we can say bacha ji V2 square minus V1 square is equals to twice of P1 minus P2 upon rho V2 square minus V1 square beta. P1 minus P2 pressure drop beta mention na beta. What is the pressure drop? S. There is mentioned here pressure drop. Beta how much? 10 bacha per day. Now bacha ji 2 into bacha this is 10 beta. Density beta what mention? 1.25 beta ji. 1.25 10 to the power 3 beta. You can see 1 cancel bacha. Okay, so beta you can say V2 square minus V1 square. Bacha ji this you just remove here this 2 decimal beta out. So you can see beta 200 by 125 beta 00. This again cancel. So you can write my dear this what 2 upon 125 beta g 2 upon 125. This is beta what will get 2 upon 125 bacha what V2 square minus V1 square. Okay, finally here I can see we have a relation from here bacha V1 by V2 beta. We have a relation my dear V1 by V2, right? Student we have a relation V1 by V2 beta. This is a relation already we got here. So beta this value you can feed over here students, then you will get here V2, right? So bacha they what they ask bacha, calculate the rate of flow rate of glycerin. So beta we have to find bacha party flow rate finally over here. So beta in last part I'm not solving here, right? So just I'm beta giving you suggestion here for this question. Okay Atharva, very good. In step 3 bacha what you can apply? Simple bacha for rate of volume flow rate, that is what Q is equals to bacha. This is the rate of volume flow rate. You can use beta equations of continuity. It's nothing but A2 B2 bacha. Further solve beta will get answer. Okay student, so now this is enough for today class beta. I'll connect you tomorrow as usual 9 o'clock. God bless you everyone to be a part of today's live session.